All right, so in the last session, we were discussing the rectangular glyphs. So as I told you, there are two possibilities. One is the possibility of drawing an axis aligned rectangle. So you have to mention the top and the bottom arguments in the left and the right argument because rectangle has four corners. So four corners means four parameters have to be mentioned. The top, bottom, left and right together will form those four parameters. So you can see p dot quad is the function that you have to follow. So top values, the bottom values of the rectangle, the left and the right values, and accordingly the rectangular would be formed. So it will give you three rectangles. For first rectangular, the top is 2, the bottom is 1, the left is 1, and the right is 1.2, and so on for the remaining rectangles. In an arbitrary, you have to mention the RECT, p.rect is the function. So you have to mention the x and y values. Okay, there is no top, bottom, all that stuff because we are specifying a center point now. So these are the center points of my rectangle, and accordingly, I need to specify some other parameters like width, height, color. Angle is a very important parameter because this is where from which the rectangle will take a turn. Pi is 3.14 by default, and then the height unit according to the screen we can adjust it. So we have given height underscore units equal to screen and show p. So I just show you how this works. If you are going for a aligned rectangle, axis aligned rectangle, where we have mentioned the top, bottom, left and right coordinates of a rectangle. So this is how you can expect your rectangles to be. So as I told you that these are the coordinates for three rectangles, so I can see three rectangles being placed in my plot. And similarly, to draw an arbitrary rectangle, now this is for arbitrary rectangle. So here I have made an additional import. I have import pi from the math function because we are using it in the angle feature. So again, here while specifying the figure parameters, the x and y basically are the center coordinates of the rectangular. So again, three rectangles would be there. For every rectangular, x and y are showcasing the center coordinate, and I need, and accordingly I have mentioned some other parameter like required width, height, and color, and at what angle the rotation should happen and all that stuff. A little bit of mathematic work that is there. So all those people who are involved in mathematics, it's a great thing for them. So let's run it, and let's see what we'll get. And yeah, this is what we get. All right, so these are arbitrary rectangles. So since I have mentioned angle pi by 3, so rectangulars have rotated by that angle. So pi by 3 means 3.14 divided by 3. Accordingly, the rotation you can see there. If you don't specify the rectangle, they will not rotate. They would be in a straight shape. So that would be the difference. You can try this, yourself. So there's few things that you should do. Everything should not be from my side. Okay, and that will give you the confidence of working on Bokeh and Python as well. All right, so from rectangle, let's go to oval and polygon. Again, there are the two different glyph methods which Bokeh supports, and you can introduce ovals and polygon shapes as well. So it's the p dot oval that you have to look for. Again, the x and y would be the center coordinate, center value of every oval. So again, I have mentioned 3x, three values of y. So that means I'm asking for to make three oval shapes. Width, height I have to mention because without that, because here since I'm mentioning only the center coordinate values, so the size of the oval will totally depend upon these width and height parameters. Then color, angle I wanted to rotate, so accordingly you will find a little bit of tilted oval that will just see when we'll run it into the interface. Okay, and similarly if you want to do polygon, then the ellipse method is there. Okay, so in the ellipse it will give you a polygon shape. Now this was for oval. Okay, so in here the only difference is that you have to use p dot ellipse, and more or less things are same. See, the ellipse takes the same properties as we have done for oval and rectangle above, but it will give you an ellipse shape rather than giving an oval or rectangle. It will give you an ellipse shape. Okay, so let's say this is what we are importing. So this is the math function. From math we are importing pi because we are using it in specifying the angle. Then output file, we have been doing it from the very first lecture that we have to mention the output files. Then figure parameters, the width and height, what I want for the entire plot area, and then the ellipse. So x and y, again the coordinate values, center coordinate values for every ellipse, and then the width. Now, if you see, for every ellipse, I have mentioned the width. So far, when we were doing for example, we have done oval. Oval, there was only one value of width. Similarly, rectangle, there was only one value of width. But that's not the case when we are doing ellipse. So for every ellipse, I have mentioned different width size and rest, angle, height, and the color. Color. These are the HTML codes I have discussed with this here Matplotlib as well. So you can just go on to the Bokeh resource and you can showcase, see there what all color codes are available. Okay, so that will give you the ellipse. So this is something which I have, combined all the things together. So in this one single code, I have taken rectangle also, oval also, polygon also, and square also. Square can also be there. So this is one single code, and all the four possible glyphs are have been, imparted in this. So let's do it on the interface. Let's do it on the interface. Uh, let's start with this rectangle is done. So okay, let's do with the oval. Okay, now this is for oval. So this is the required import that we have done. Okay, so this is the figure parameter, and now this is p dot oval. So I have mentioned the required center coordinates for x and y, the required width, height, color, angle at which I want to rotate, so that it can give me that nice little oval shape. All right, let's check it out. Let's check it out. Yes. Again, you can see the tilt. This tilt is basically because we have specified the angles. Okay, let me remove the other plots that we are done with. So, it's tilted because I have mentioned the angle here. So if you don't mention the angle, it will not be tilted. As simple as it is. That's what you need to do. Okay, so that's the ellipse that, sorry, oval that we have do. For ellipse, you have to use the p dot ellipse function. The difference is you have to mention the width for every ellipse, which was not the case with oval or rectangle that we have done above. So if I run this one, this particular one, dot p dot ellipse. So let's see how this comes out. Yeah, so you can see these are the ellipses that have been mentioned. These are not ovals. Okay, so now they're of different width. This its width is different. His its width is different. Its width is different. If you will mention one single width, then all the three would be of same width. But since I want them to be of different widths, so I have specified different widths. The same type of customization you can done with ovals or the polygons above as well. All right, so it is not like that it cannot be done. So you can customize it and the way you want to showcase. Okay, I hope it is clear. And this is the combined one where I have taken the four. This is for rectangle. Okay, then this is for square. Square, again only x and y values, the center values, and then the size, whatever size I have mentioned. So accordingly it will wrap the square around that center. And then ellipse, I have mentioned this is for the ellipse, and then finally oval. So four glyphs in one single plot. Now that's a beauty. That's a beauty that you can just see here. Just notice here. See what will come. Wow, that's beautiful. That's beautiful, right? See how it has come. Lot of things can be done with this stuff. That's the power of bokeh. The level of possibilities it opens for a data analyst or for a scientist or for an engineer are awesome, are super awesome. You can put up anything. You can visualize things as you want or the way you want. That's the level of customization bokeh introduces into, which was not at all viable when we were talking with Seaborn or the Matplotlib library. Okay, so that's about the rectangle, oval, polygon, and we have covered square as well. Okay, so angle parameter, as I described above, that it determines the rotation from the horizontal. So that is why our ovals or our polygons have been little tilted, rotated, because I have mentioned that angle parameter. If you don't want to mention the angle parameter, you can simply remove it, and it would be the horizontal tilt. The tilt from the horizontal will not happen. That's the only difference. Like for in this case, I have not mentioned angle anywhere. In oval, I have just mentioned oval, so oval is little tilted. And ellipse, I have not mentioned angle. Square, I have not mentioned any angle. Rectangle, I have not mentioned any angle. So that is the reason square, ellipse, and rectangle all are straight figures. Means there is no rotation from the horizontal. They are fixed. There is no rotation. The rotation is only in the oval because I have mentioned angle minus 0.4. Okay, so that's for rectangle, oval, and polygon. Uh, Moving ahead, we'll come on to again very interesting session, which is for wedges and arcs. Let me mark you an introduction on wedges and arcs. That is again one of the most powerful feature of using bokeh. Introducing arcs and wedges in your plot. There's not much difference between wedges and arc. They are more or less synonymous terms with a little difference. So wedge is basically a filled arc. So if an arc is not filled, it's an arc. If it is filled, it's a wedge. As simple as it is. So arc method, it draws a simple line arc. Again, you have to give x and y coordinate, and along with the x and y coordinate you have to mention the start and end angle as well, and the radius, because without radius arc is not possible. So how much radius you want from the center, that is very important. What is the start angle of the arc and what is the end angle of the arc? Little mathematics, but that is, that's why I say these, if you're a statistician or mathematician involved in all this stuff, you are blessed with book actually. So angles are given in radians. Radius may be in screen units or the data units. Wedge is a filled arc. So that's what I mentioned. That wedge is nothing. It's an example of filled arc basically. So you fill the arc, it becomes a wedge. That's it. I'm not talking about potato wedges. I'm talking about wedge as in from the arc. Okay. All right. Let's move. So optional directional property. So it means you can mention whether the movement has to be clockwise or the anti-clockwise. So the direction of arc or wedge, in which direction they should render on the plot. That optional direction property is also there that you can do in this with the help of bokeh. Okay. So all right. So this is what we're gonna do. The necessary import of from the bokeh.plotting interface, the figure parameter. Now this is p.arc. This will introduce the arc. So again, x parameters have been there, y parameters are there. Again, since I'm mentioning three values, there would be three arcs. Then I'm mentioning the uh, required radius. Okay, start angle, end angle, very important, and the color. Okay. If you want to do wedge, as I told you, in wedge you have to fill the arc. Okay, so I'm picking the same parameters as above. Okay, radius, start angle, end angle. Color I'm changing here. Color I mentioned was navy. Here I'm changing it as fabric. Then alpha is zero point 0.6. I told you alphas are basically help you in the dark, the level of colorness in your fill, whether it's on a higher side or on a lower side. And then the direction. So this is an additional optional property, as I told you, that if you want your arc or your wedge to render in a certain direction, clockwise or anti-clockwise, so that facility is definitely there with this bokeh plot. Okay. And there are two more things that we can do with the wedge. So this is the annular wedge. There's another function related to arc that you can do. So the only difference is if you are using annular wedge method, then it will draw a filled area. Okay. So there are two more parameters that you need to mention. You need to mention the inner radius and you need to mention the outer radius as well. So in the above cases, only radius parameter was there. Only radius. So if you want to place a simple arc or a filled arc, only radius parameter is there. But if you want to fill the arc, or sorry, if you want to draw a filled area, then you have to mention two more parameters. Once I will take you to the interface and I will show you that what's the difference between simple wedge and an annular wedge. We'll come to that, don't worry. And then finally there is another function that is there in the arc, which is annulus function. So in the annulus function, again inner and outer radius is there, and you can draw filled rings here. Okay, So filled rings are there. So you have to use p dot annulus again. So these things might look similar to you, but once I will take you to the interface and will showcase you how this works, you will actually be able to understand that what's the difference between all the four things. Okay, so simple arc, that's one case. Then wedge is a filled arc. Then annular wedge, which gives you a filled area. It will take two more parameters. And instead of annular wedge, if you take the annulus glyph method, then it will take few more. The parameters will same, but the way the plot is represented will be different here. Okay, so we'll come to that discussion in the next session. Till that time, keep revising, keep plotting. Thank you so much.